Hello guys, welcome to Solving Solutions, your number one channel where I get solutions to all your solving problems. It's 9th Avenue in class again today. How have you been? On today's tutorial, we are going to look at the Topographic Wetness Index, right? Good. So, it's a commonly used index in hydrology and geomorphology to quantify the effects of topography on the location and extent of wetness of wet areas in a landscape, right? Good. Now, it is useful for identifying potential area of soil saturation, runoff generation, and the spatial distribution of soil moisture. So we have a formula here, the natural log into A divided by tan B, where A is the upslope that will be gotten derived from the flow accumulation, still from the dam, and then we have the B gotten as the which is rather the slope angle, still calculated from the dam, right? Good. So from our digital elevation model, we are going to carry out those processes. So the first of which is we need to fill the dam. So let's come to the spatial analysis tool. Then we go to hydrology. Then under hydrology, we double click on fill, right? Good. Now we also want you to note that your digital elevation model is best used projected, right? Good, for analysis like this. So there are videos, or there's a video on the channel that will show you how to reproject your raster, so you can check that out to help you if you have your digital elevation model in a geographic CRS, right? So from the source, we can see the linear unit meter, and then we can see the XY coordinate system to be zone 32, right? Good. So the first thing is that our input raster, it fills the sink in a surface raster to remove small imperfections in the data. So the input will be what the projected them. Good. So there's a default output surface raster that has been created. We are going to work with that, and then for the Z limit, you can always read what the help by the side, right? Good. So we are going to leave it empty as default, and then we click on OK. Now if you have a shapefile that is actually defining your area of interest, you can decide to come to environment and then maybe work on what the processing extent and all of that, right? Good. But since we already have clipped our digital elevation model to our area of interest, we might not need that, so we click on OK. Good. So the demo has been filled. The next part of the tutorial is for us to try to get what our A and our B, right? Good. So our A is what the flow accumulation, right? Good. So to get flow accumulation after filling the dam, we need to first of all calculate the flow direction, right? Good. So for the flow direction, we are now going to use the filled dam, and then by default we leave this output raster generated, and then we click on OK. Good. We have the flow direction generated. We now come to what the flow accumulation, then the input flow direction raster, which is what we've just gotten. Then we have that as our default output accumulation raster, and then we click on OK. Good. So we have what the flow accumulation, and then we can now go forward to get the slope, right? Good, because that is the other part of the formula, tan B, right? Good. So for us to get the slope, we leave hydrology, and then we come up to surface. Then on that surface, we double click on slope, right? Good. The input raster will definitely be what the field them, and then we actually measuring the slope in degrees and not percentage rise, right? Good. So you can read the description here that defines whichever method it is. So we click on OK. Good. Now the slope has been generated. However, there is a note that we need the slope in radians for calculating our TWI, right? Good. So we are going to use the raster calculator to help us convert the slope we have in degrees to radians, right? But now there's a constant that if you want to convert from degrees to radians, you multiply by pi over 180, right? Good. So if you use your calculator to do pi over 180, you are going to have 0.017. So we are going to use this constant to multiply that our slope in degrees, right? Good. So this constant can be gotten by using the pi constant divided by 180. So let's come up here, we close the surface, and then we come to map algebra raster calculator. So remember, we want to convert the slope in degrees to radians, right? Good. So we have slope multiplied by the constant we have actually copied, right? Good. So let's call this slope in radians, right? That's slope underscore RAD. Good. So we click on OK. Good. We now have our slope in radians. So coming back to our guide, we've gotten the flow accumulation, we've gotten the slope, right? Good. So if we come to the formula which says A over tan B, right? Good. So we can decide to just reduce our stress, and then we get the tan of our slope in radians, right? Good. So we come up to these options. We have tan, then the slope in radians, right? So we have something like this. Then for the output, we have slope tan, right? Good. So we click on OK. So this is the slope tan, right? So if we now come back to the formula for the final aspect, it will now be the natural logarithm into A divided by the slope tan, right? Good. So the A is the flow accumulation divided by the slope tan. So we come up here again to the raster calculator, we search for that function, then our A is the flow accumulation, right, divided by tan B. So we have slope tan, right? So we can decide to call this TWI because it is actually the product that we want to achieve, right? Good. So click on OK. Good. So we have the TWI outputted. However, we can still decide to work on the symbology because we can barely get any insight from this black and white, right? Good. But we have a scale here that gives us from high down to low, right? Good. So this gives us regions of high TWI and then regions of low TWI. So let's see the symbology. So we can decide to use colors with shades of blue, a ramp rather with shades of blue. Okay, or we can just use this color ramp, right? Good. So what this means is that from the scale here, regions of lower TWI are having the colors red. Okay, let me invert the scale. No, I think we should leave it this way because we are looking at a water index, right? Good, which means the regions where we have higher saturation should be blue, since maybe blue can be likened to represent water bodies, right? Good, so something like that. So we are moving from red to blue. So the blue representing regions of higher TWI, right? Which means those areas have high water saturation, right? Good. So let's still zoom to layer. Good. So this is the topographic wetness index of this particular area that shows us places of higher water saturation, which can also indicate higher chances of flooding and maybe containing water and all of that, right? Good. So we have shown you the processes, the workflow on how to generate your TWI from your digital elevation model using ArcGIS, right? Good. So We are going to see you on the next tutorial. Ensure you keep staying safe and have a very good time. Bye.